welcome to this video. My name is Mark Scythian. The date today is January 23rd, 2025, and this video is going to focus on the Zeroth Law of Thermodynamics, which is not often discussed or is somewhat ambiguous or vague at best. So all this law says is that thermal equilibrium will be reached when two or more objects reach contact with each other. They will just transfer and receive an equilibrium temperature that equalizes across all three. So here we have objects A and B at different specific heat capacities and latent heat, so that's identified as X degrees. In this case, object A has 0.25, 1/4 X degrees. So X, you can fill in the temperature. And then object 2, 0.5 or 1/2 X degrees. And then object 3, 0.25 X degrees. So we add up all of the coefficient fractions, we get 1 X degrees. So the temperature of the thermometer's reading is not just absorbing heat from the two objects A and B, but also losing or transferring its base value, which is in this case set at a lower temperature. So if this was an analog mercury-based thermometer, it would have to be set below or about room temperature or less. So it would be incorrect to only focus on the heat absorbed from objects A and B into the thermometer. We also have to account for the thermometer itself potentially losing heat as well, rather than gaining heat. But the culmination is the thermal equilibrium, the sigma T is equal to A, B, and C. So we can take the individual specific heat capacities as in their heat ratio, Cp over Cv, the coefficient of pressure over the coefficient of volume, the gamma value. So this actually correlates to the heat ratio, which then correlates to the specific heat capacity of the object. And then we have the latent heat per object, the mass and times temperature of each object. So we can integrate that into an X degrees value, and then if all three are in thermal equilibrium, then that's 1X, or just X degrees. So in this case, based on the measurements, we'll suppose that it is 0.25, 0.5, and 0.25 as the summation. So when we take the fractional values, their product sums, we get then an equilibrium temperature. So that's what would show up on the thermometer. So the theoretical versus the actual temperature are not necessarily identical. The thermometer is a thermal equilibrium device, and so a practical application of the Zeroth Law of Thermodynamics is use of a thermometer. Thank you for watching this video and have a great day.